I hope a more intuitive way to think about logit regression is to think about it in terms of the way that we've thought about regression in the past. There's a linear relationship between x and y. And in the past with OLS, we've at least forced that linear regression to have a linear relationship between x and y. But in this case, we know that our outcome variable, which is binary, is not going to allow for that. So that's why we're using a different functional form to represent essentially the linear relationship between x and y. So in other words, we can look at the left side of this equation as essentially just the log transformation of the probability that y is going to equal 1. And on the right side, that's just the linear regression model. So essentially, the logistic regression model is just a generalized linear model, or a GLM. And that's kind of an important acronym to remember because that's actually going to be the name of the function you'll call in R to conduct a logistic regression. And we're only using this type of GLM because we have a response variable that's binary. So you could imagine that if we have a response variable that was not binary, but we still was not continuous, so we can think of ordered categories. That's something that we'll discuss in later modules. That's still a GLM, but we're going to use a different functional form. In this case, we're using a logistic formula, right, to explain how the expected value of y changes conditional on x. Or in other words, how the probability of having CHD changes based on that value of x. Now here, I'm not doing anything fancy. I'm essentially just rewriting the equation to show you that in fact, that log transformation of the probability that y equals 1 is in fact equal to the linear regression model.